I'm John from Optics for Hire, and I'm going to talk about how the refractive index of a material can impact an optical design. The refractive index is a number. It's a number greater than 1, and it relates to the speed that light can move through that material. Air has a refractive index of right around 1. Water has a refractive index of 1.33. And if you're ever swimming under the water and look up, you'll see that you can't see the scene directly above you. It's changed. Or if you're ever looking down into water, you can sometimes see a mirror, and that's because of the different refractive index of those two materials. Sapphire, which is a material used in a lot of optical systems, has a higher refractive index. So as I mentioned, it's used for calculating the speed of light as it goes through a material. It also can have different values at different wavelengths. One of the reasons, or the reason, that you can see sort of a rainbow effect on a poor quality lens is that the different colors of light, red, blue, and green, are moving through that lens at different speeds, and they haven't corrected that lens for what's called chromatic aberration. And so a lens designer will use different materials together to correct chromatic aberration, and those different materials will have different refractive indices, and by doing that they can make a lens that doesn't have that rainbow impact. A final thing to note about refractive index of a material is that it can change with temperature. So these are some of the key points to understand for any engineer designing an optical system. Understanding that light moves through material at different speeds, and that can help and hurt in the design of different kinds of optical systems. Thanks, and if you want to see a much more detailed explanation of refractive index, including the formulas, you can visit our web page, and I'll provide the link here.